Welcome to Pindar Poetry. We hope you learned something new.
You start with the essentials and the first actionable step. Lay out a compact grid for binary inputs. This gives structure and simplifies wiring. Once done, build input toggles using levers or item detectors so signals are stable. This prevents glitches. Make sure to place repeaters to set timing and comparators to read strength. Those choices control signal resolution and determine how many layers your network can support. Now begin wiring the first logical neuron with repeaters and dust. That blueprints your computational unit. Next, you construct hidden layers where the computation actually happens. Use pulse length encoding or item count delays to represent weights, because timing maps naturally to real-valued influence. Once done, sum inputs with comparator chains, and implement activation thresholds using piston or tile entity gates. This gives you nonlinearity. Make sure to route signals with observers and repeaters to maintain tick alignment. Timing mismatches break learning dynamics. Then replicate the neuron module across the layer, staggering the layout to minimize redstone crosstalk and reduce lag. Finally, hook the last layer to a clear output, a lamp matrix or item-based display so you can read predictions quickly because visible feedback speeds iteration. Then train by adjusting pulse lengths or item counts. You can use recorded examples to tune weights or build in-game scripts to automate batch updates. If things go wrong, start with one key troubleshooting tip. Desynchronization is the most common issue. Resync clocks, add repeaters, and simplify a suspect wire bundle to trace the fault. Make incremental changes and test after each change.
Thanks for watching. Consider subscribing if we helped you.